Welcome to FXR Conversations. Have you ever, wished you could just freeze time and look right through a solid object to see what's happening inside? Well, in this short introduction, we're exploring a technology that lets scientists and engineers do, pretty much exactly that. It's called flash X-ray.
That's right. Yeah, flash X-ray, it isn't just about, seeing. It's really about revealing what's completely invisible during these really dynamic, super high-speed events. And what's fascinating, I think, is where it came from. It actually started during World War II.
Oh, really? Wartime?
Yeah, researchers were independently trying to figure out, how fast-moving things like shaped charges actually worked. And that need, that urgency, it kind of kickstarted this whole field. It's amazing how that innovation has spread into so many peacetime areas now: material science, safety.
Okay, so if it can peek inside things and sort of slow down time, how does it actually do that? What is flash X-ray really at its core?
Well, fundamentally, it's a type of non-destructive testing. It works by generating these incredibly short, really high-powered X-ray pulses. We're talking nanoseconds here.
Nanoseconds, wow.
Exactly. Think of it like a camera with a shutter speed that's just astronomically fast. It can quite literally freeze something like a bullet in midair, but using X-rays, so you get no motion blur, just a really crisp internal snapshot. Even if the object is moving, kilometers per second, you get this clear internal picture.
Kilometers per second. And you get that image instantly, like a digital image right away.
Instantly. No waiting for film.
That must speed things up dramatically for research and development, right?
Oh, absolutely. That immediate feedback is, well, it's a game changer. This technology is just invaluable across testing, development, scientific research. I mean, imagine being able to inspect helicopter blades while they're spinning.
You can do that.
Yeah.
Check for internal flaws.
Yeah, or analyze munitions during flight, see exactly how they behave, or even watch what happens inside, say, a bulletproof vest when it gets hit. It lets you visualize those internal changes, even if there's smoke or fire or even steel in the way.
Even through steel.
Yeah.
So you can see things you just couldn't possibly see otherwise.
Precisely. It's not just about seeing a failure. It's about understanding why it failed, down to the nanosecond. Revealing things traditional methods just miss.
And you mentioned digital images. So researchers can probably enhance those easily. And I think you hinted before, maybe capture sequences.
Exactly right. The digital format makes enhancements straightforward. And yes, the image plates or detectors, they can often take multiple exposures very quickly. So you can create almost like a little X-ray movie of a super fast event.
Like a stop-motion X-ray film.
Sort of. That versatility is really key. You can set things up for 3D stereo views if you need depth perception, maybe using 2 X-ray sources, or as we said, generate those cinematic sequences for studying high-speed motion.
That's an incredible range. So how do they pack all that capability into one system? What are the main components? What's actually in the box?
Okay, yeah. So a flash X-ray system, it really boils down to 2 main parts. You've got the X-ray generation bit and the image detection bit. For generating the X-rays, you use these really robust X-ray tubes. Scan-to-flash makes some well-known ones. Often they have user-serviceable anodes. That's the part that wears out, basically, so you can replace it easily.
Yeah.
Makes them more maintainable.
Okay, tubes. And what powers them? You need a lot of energy fast, right?
You do. That's where the pulsars come in. They're essentially high-voltage capacitor banks designed to just dump a massive amount of energy into the tube extremely quickly in that nanosecond pulse, and they recharge fast too, ready for the next shot.
Got it. Tubes and pulsars. So what about capturing the image side, especially for those cinematic sequences?
Right. For the dynamic stuff, you often use what are called cinematic imaging detectors, or CIDs. These are special screens that glow. When X-rays hit them, they convert X-rays to visible light, and then you point incredibly fast cameras at those screens. So you're basically filming the X-ray shadow movie in real time.
Wow. Filming X-rays.
Pretty much. The whole setup is computer controlled, naturally. Lets you run things precisely, often remotely too, which is good for safety. And it's worth mentioning, a lot of modern systems use compressed dry air for insulation instead of older methods. It's more eco-friendly.
That sounds incredibly complex, but also very sophisticated.
Yeah.
Now, X-rays. People always think about safety. How is that managed with these powerful systems?
Yeah, that's obviously a critical consideration. Safety is absolutely paramount. The equipment itself is designed with safety in mind, shielding and containment. But more than that, there are loads of effective solutions available today for managing and containing X-rays properly in a research setting. When you follow the right procedures for testing and development work, these systems are designed to be safe and honestly quite straightforward to use. Researchers can focus on the science securely.
That's good to hear. It really is amazing how this technology, flash X-ray, lets us see things that are just way too fast or completely hidden from our eyes. It really pushes the boundaries of what we can observe and understand.
It certainly does. This ability to see the nearly impossible, as you put it, it offers just unparalleled insights into how things work under extreme conditions.
It makes you think, doesn't it?
Indeed. It really offers a whole new lens on reality, showing you the mechanics happening in moments that are otherwise just a blur. It kind of leaves you with a question, really. What hidden dynamics, what unseen events might you be able to uncover in your own field now that you know tools like this exist?